Okay, great. So we are now live. I think we've got people kind of filtering in a Bijou group today, so it'd be really interesting. I think, Mike, I'm not going to introduce you because you're going to introduce yourself as part of your presentation. So I think maybe we'll get started. I can hand over to you, give you the reins, and you can go through your presentation, if that's okay with you, Mike.
Absolutely.
Fantastic.
All right. Well, good morning, good afternoon, good evening to everybody out there in Crowdcast land or TV land. Thank you for joining us today. Let's get started with the presentation. Oh, that's sharing event. Oh, wait, here it is. Okay. Okay, so welcome to Driving Innovation in Automotive Software. Let's go back in time a little bit and look at some of the vehicles that we all drove back in the 1970s. This is a 1972 Chevelle SS, one of my favorite cars from back in the day, along with the other GM muscle cars. Then today, we'll have things like a Rivian, and there's different models out there for that. I had a chance to see these up close a few months ago, and just to give you an idea how things have evolved as well, if you haven't been to a Rivian showcase, it's not your standard dealership. It's basically like a small showroom, and all of the paperwork is done online to buy one of these. So I thought that was interesting. And then the engines of that time frame from back in the day, you have here normally aspirated V8 engine in this case, that you can see that there is a distributor cap that had a set of points that rotated to direct the electricity to the spark plugs, right? You also had a carburetor, and that's the air cleaner on top. So, but today you have engines like this, and they come in all shapes and sizes, of course, right? So this is another V8. The big difference here is that there's the a different ignition system. You have fully, fuel injection, things like that. So that's how these things have evolved. And of course, fuel injection has been around for quite some time. And also working on these vehicles back in the day, I see a technician here using an oscilloscope. And I have to disclose that I use Gemini to generate these images. You can see that the probes were actually just actually put just on top of the plenum, the air plenum for on the engine. But that wouldn't be true. But you get the idea. And similarly, today now we use handheld devices and things like laptops and other digital tablets and things like this. So hello, my name is Mike. This is current Mike. I'm a Java champion. I'm a director of the Garden State Java user group. I've been writing for InfoQ since 2016. I work with Payara as a contract dev advocate and tech writer. And I'm involved in Jakarta EE as a committer on a couple of the specifications. The vice president of the Jakarta EE ambassadors, and I wrote my first book that came out just under a year ago, known as Heladon Revealed. So, and I do all this in retirement. I worked for ExxonMobil for 33 and a half years and retired 2.5 years ago. So all this stuff like you see here is actually just my passion. So and I have the time to do this a lot more than I used to have. So but there was a former Mike, or my early life, and that picture of me was look at all the hair. That's all gone now, unfortunately. But yeah, I got into ExxonMobil because of my experience working at various General Motors dealerships. I worked Chevrolet, Buick, and Pontiac. I also, had formal training, to be an automotive certified, Class A technician. So I made my way up to that status. But again, that's how I got into Exxon, and the rest, as they say, is history. So, and I really like this picture. This is back from 1989 in the test car lab in Linden, New Jersey. This is Heritage Exxon. And they did a number of these pictures with the technicians at the time that were roughly, I don't know, 16 by 20 or something like this. They were all hung in the lobby of Building 2. Was able to, a friend of mine sent me that picture, which I had hanging for the longest time, and I handed it off to my friend Herb, who you see on the right. And you can see the main thing I wanted to point out here was the huge oscilloscope that I'm standing next to. And then Herb is, he has his hand on a distributor cap, as you can see. So, that was then. Again, look at all the hair. That's gone. But this is a fun picture. I really cherish this still. And so anyway, that was back in the day. So, all right. So enough about me. Let's talk about the evolution of automotive technology. So early on, before electronic computer control or anything like this, everything was mechanical, right? The engine was everything. There was no electronic control at all. It was until like 1980, 81, 82. You had General Motors had their computer command control. And Ford had their electronic engine control, EEC4, EEC5 back in the day. And Chrysler had a feedback carburetor system using an electronic control unit. So, and then things stayed that way until about 1996. And the onboard diagnostics, or OBD2, standardized a lot of this. So a P0420, for example, which I believe is an O2 sensor, fault or at least a concern with it, would be the same on most vehicles. And then you had, there's connected vehicles, equipped with wireless communication. Now, I haven't seen any examples of this to exchange information with other vehicles and such. We did have a 2021 Subaru that would actually email you if there was a problem with, like, say, tire pressure or low oil or things like this. So, there's that connected vehicles example of that. So this was quite useful. Software defined cars, they're vehicles primarily controlled by software. I've seen an example of I think it's called Wago. It's self-driving taxi in excuse me, in San Francisco. I did not get in one. I've seen them on the road. So this is where we're heading these days. So, and then I found this, an example of this on connected cars, interchange of data. So you have all these here, vehicle to pedestrian. That would be interesting, actually. And vehicle to vehicle. Now you can imagine, I live in New Jersey, and you can imagine a vehicle to vehicle communication. I don't know. It would be quite interesting, especially with all the road rage out there. But in any event, so these are the ways that a vehicle can communicate with infrastructure. All right, the developer's challenge and migration blocks, right? So let's talk about that a little bit. You need to balance legacy versus new technology. Now, this is in any industry, and even in the software industry itself. Think of major releases of software that have breaking changes, right? It's look at Spring Boot, Spring Framework. All right, they're using Java 21 as a minimal requirement. They went to Jackson 3. They implemented JSpecify for their nullability. So you have all these things to worry about. It's also, a challenge to maintain safety and regulatory compliance. And then also real-time reliability and innovation velocity. So it's, it's you need to have that reliability as you upgrade, and if you upgrade faster rather than slower. There are still legacy systems in use, the aforementioned OBD2, the CAN bus or controller area network, and any proprietary protocols that are out there. So, and there's also challenges between embedded versus cloud systems. All right, migration blockers. I know for a fact that Netflix was using Java 8 until about 2 years ago. There was a talk at QCon San Francisco with Paul Bacher, who talked about experience in going from Java 8, and I think at the time it was probably Java 17. So, it's what are the challenges, or, what is stopping you from upgrading to the latest, long-term support release? So Java 11, 17, and 21 are all long-term support. Java 25 is the latest that was released in September of this year. A lot of the technologies are compatible with 25, but when I used 25 as my standard, when I open up my terminal window, some applications don't compile because of that, so I have to go back to 21. Also, I understand there are some folks still using Payara 4. So, what's the decision to go from all the different stages of Payara? Payara 6 is now the older technology because it was compliant with Jakarta EE10. Payara 7 now was just recently certified as compatible with Jakarta EE11, which is the latest release of Jakarta Enterprise Edition. I'll have more on that a little bit later. All right. How do you migrate to the cloud? Those kinds of things. What is stopping you from doing that? And also, in any, especially a big company, bureaucracy, I had my challenges back in the day. I was in IT at ExxonMobil for a while, and I wanted to use Java. Then, well, why do you want to use Java? I can't use C++, or those kinds of things, right? So I'm sure some of you out there may have had that experience. All right, top challenges for Java-based enterprise applications. Some industry thought leaders were asked about certain questions about this particular thing. So these are the 7 challenges, and we'll go through all these. I have a slide for each one, so I'm not going to announce them all here. So the first one is automotive systems need real-time data processing at scale. So in the responses from these thought leaders, these are just I went through and and parsed through all this and sort of bullet pointed everything. So there's a need for fast and reliable processing of data from thousands of cars in near real time. And the data would be, the position, speed, engine status, so all those normal electronic computer control type of variables that are out there, right? And for a car. There's a use of special services that work separately so that the system doesn't freeze if one module is overloaded. Today, well, for the last few years, there's observability, there's health checks, there are fault tolerance. So, those kinds of technologies would address that particular bullet point. Applications need to easily connect to third-party services, right? So insurance platforms, well, that makes sense. Back in my day, in working at the dealership, there were cars that were stolen, and they got towed back to the dealership, and the techs would repair things like the steering columns and all that, right? So this is the kind of stuff that applications or automotive applications need to do. Conflict with new modules as new features are introduced, right? So again, this is even with software. They were able to make things compatible by containerizing each module so that it runs in its own environment. And then modifications may be tested in a virtual environment. So that's kind of like a workaround, that some of the folks were doing. And applications, allows for applications that are stable and fast and can be updated in the future. All right, Java platforms face real-time data synchronization challenges, right? There's a struggle to keep real-time data consistent across the distributed vehicle systems. So, same thing with distributed systems in software, right? They said, and I don't I don't know how it is, but it's more difficult in the automotive industry than other industries. So this is, what we were told. Keeping data synchronized with low latency, high reliability, with all kinds of technologies like telematics, edge devices, enterprise backends. They use modern stacks like Spring Boot and Quarkus to help, to address this. And the premise is that it's built on a solid microservices or container platform. And the overall goal is to treat Java setups as a single scalable platform and one that grows with each new model feature and automotive data streams. Okay, enterprise software is in the automotive industry must move as fast as innovation. I mentioned that earlier, right? It should never compromise reliability. So this is obviously very important. The toughest challenge is to modernize legacy systems while maintaining safety, compliance, and uptime. We'll talk about how that's accomplished today. There's an example that we were given that says a global automotive supplier needed to transform a 10-year-old Java-based telematics platform into one that's agile enough for connected vehicles and over-the-air updates. And yeah, I meant to mention before too, your vehicle can get upgraded firmware and software, over the air as it's mentioned here. And so that's kind of cool, actually, if you think about it. The result was that updates that once took months now roll out in weeks. So this was kind of cool. So, and they used modular Spring Boot services to take care of this. All right, enterprise applications need consistent APIs across all the different services, right? There's a pain point in managing large enterprise applications that move across critical logistics data. We were told that there's chaotic debugging when scaling a route planning backend due to each Java service having its own data sync logic. And we were also told that complex systems fail at the seams. I think this makes sense, if you think about it. When I first read this, I'm like, yeah, I can see that happening. The key takeaways here from all this is to build a single source of truth for all service data, to keep clear API contracts between modules, even if they're in-house. That makes sense. Track performance regressions early before an impact on users. And then API consistency keeps everything moving. That performance regressions, I know there's, a lot of software out there that, they put out a point release and next thing you know, there's a maintenance release 2 days later because of a regression of some kind, right? So there's been many examples of this. All right, integration between legacy systems, right, with modern frameworks. Automotive clients rely on Java-based systems for supplier data and logistics tracking. There's a consistent or a constant challenge with integration. And then many factories still use legacy ERP tools that don't play well with newer Spring Boot or Jakarta EE frameworks. Yeah, I can see that for sure. A top priority has been creating lightweight APIs that bridge these systems without overloading performance. And security and real-time scalability, of course, are very, very important. And they had one major win coming from modularizing the architecture, which cut the deployment time by 45%. So that's quite good. All right, what do we have? Zero latency. All right, and this is obviously critical for automotive enterprise apps. developing enterprise applications are defined by a single challenge. So it's striving to achieve the absolute transactional speed, or just, the throughput, essentially, with that, how that translates. With zero data latency, systems cannot tolerate multi-second startup times and consumption, large consumption of resources that are common in legacy Java deployments. And we'll talk about this later in terms of, these kinds of things about warm-up times. The Java language has evolved over the last couple of years with this. So we'll say that for the end. The cost of latency is a direct financial loss for customers, and traditional Java EE systems are too heavy and too slow to process real-time queries. Now, I'm going to stop here a second and say that it was written as Java EE systems. The last Java EE release was Java EE 8 in 2017. As you may know, Java Enterprise Edition was donated to the Eclipse Foundation from Oracle and is now open source. This particular, claim here about systems being too heavy and too slow, I think could be a thing of the past right now, based on the way specifications have evolved. So that's my interpretation of that, and that makes sense, right? There was a lot of older, technologies with Java EE back in the day. Modern frameworks like Quarkus or highly optimized Spring Boot environments enable rapid cloud-native deployment. Yes, absolutely. And we'll talk about microprofile and all that in a little bit as well. System must perform hot reloads and minimize memory footprint. All right, that makes sense. And finally, as security links modern Java with legacy manufacturing systems, it's important that there's integration of modern Java apps with legacy manufacturing systems. Security being a main priority. We were told that connecting old and new systems can invite malicious actors. How many CVEs do we see out there these days, right? There's plenty. And, in my research every week for my Java News Roundup that I put out there, I see a lot of references to a particular release saying, we've addressed this particular CVE. So, and then there's a key requirement in achieving real-time data processing at scale. And so we were told that to solve this, there's a focus on building secure, scalable architectures in hybrid cloud environments. All right. Ooh, we got through that. So let's talk about some current Java-based technologies right now. We have here Java 25, of course, the latest long-term support release, Jakarta EE11, microprofile 7.1. I have 2 slides on the specs on that to talk about it. Payara platform, as I mentioned earlier, version 7 now is certified as a Jakarta EE11 compliant. Glassfish 8 is on the verge of a GA release, probably later this month, from what I recently heard. They have their 14th milestone release right now. They too are even their milestone releases are used as certified for particular specs that were released for Jakarta EE11. Then last month was the release of Spring Boot 4, Spring Boot 7, Spring Security 7, along with some other Spring ecosystem projects that are out there, a lot of them that are aligned with the 2 main ones right there with Spring Boot 4, Spring Boot 7. The big features in that is they're now using Jackson 3.0 for their JSON processing, and then also a technology called JSpecify. They provide various annotations for nullability. So this is JSpecify is a set of organizations that have gotten together to work on this. I believe Google's one of them, JetBrains is another. I'm trying to remember some of the others, but you get the idea that this is a collaboration among various organizations. So I think this is a cool thing. JUnit 6 was just released, so that's the latest and greatest in testing. And then we'll talk about open rewrite and modernizing legacy applications. All right, so this is the latest set of specs proposed for Jakarta EE12. 11 was released in June of this year, although it was a staged release. There are 3 profiles. There's the platform, which are all these right here that you see in front of you. There's the web profile that is a subset of that for web applications, and the core profile, which has about 7 specs such as CDI, JSON-B, JSON-P, and RESTful web services, among others that are for just microservices-based applications. So the big thing here, and this was very important to note, that Jakarta EE11 was supposed to be fully released in July of last year. However, it was at some point it was decided to say, hey, our technology for the technology compatibility kit, or the TCK, in which everything is validated. Now, these are a series of thousands of tests that take hours to run for compatibility. And it was decided to upgrade those technologies. So in other words, Ant as a build tool was then migrated to Maven. I still like Ant, by the way. And then things like the test harness, the Java test harness, then it was they migrated that over to Arquillion, which is another testing framework that's out there. And they decided to delay everything. So everything was released in stages. The core profile was released in December of last year. With only 7 specs, you can see that this was easy to accomplish in getting that done. The web profile was released in, I want to say April of this year, and then the full platform was released in June. So this will lead the way to more efficient releases. And right now with Jakarta EE12, the intent is to have it released in July of next year. So only a little over a year, between 11 and 12. We'll see how that works out. Milestone 1 was just recently released. Milestone 2 is scheduled to be released next week. So anyway, so these are the specifications. You see the ones in blue will be updated. There should be 24. Jakarta Query is the new one that was a brand new spec and automatic, not automatic, but it was voted in to be part of the platform already. And then in the upper left, you'll see Model View Controller 3.1 and NoSQL 1.1. These, I know NoSQL there will be a vote to include it sometime this month, probably. And then I'm not quite sure of the status of NVC yet. So. And then we have MicroProfile. MicroProfile was born out of Oracle, being, let's say, how we say, there's no nice way to say this, but they were slow in releasing Java EE8 because 7 was in 2013, I want to say, and things kept getting delayed. So MicroProfile was a collaboration of Red Hat, IBM, Payara, and Tommy Tribe. They came up with the original 3 specs, which would be CDI, JSON-P or JSON processing, and RESTful web services. These specs were considered minimal for a microservices type application. Now, since then, these that you see here, REST client config, fault tolerance, these were homegrown because it was open source and by the Java community. And then things have evolved, and this will take quite some time to explain because things have changed. Metrics was in the core set of specs. Now it's a standalone because how OpenTelemetry became, a marriage between Open Consensus and Open Tracing. So then telemetry offers metrics as well. So Open Tracing and metrics, as you see on the right, are now standalone. So, and then core profile that you see in the set of core specs is those original 3 specs that were in MicroProfile 1 in 2016. are part of that core profile. So it's, like I said, having fault tolerance, basically saying, hey, if something breaks, how do you recover? There's retries, how many times do you want to try to, resolve something that happens in your microservices? The health spec says, hey, am I up or am I down? If I'm down, respin up a new instance of that microservice, for example. So these are great specs to do that. So this is something to consider if you haven't already done so. And then finally, open rewrite. This came out a few years ago, I believe. We were lucky enough to have Jonathan Schneider to present open rewrite at my Java group a couple of years ago. So it's an automated refactoring ecosystem, right, for source code. It has an auto refactoring engine, and it uses these lossless semantic trees that are deterministic, composable, auditable, and battle tested. And this is how, when you want to upgrade a legacy system, you can use this tool for that. There are built-in recipes to get that done. And also there are Maven and Gradle plugins for your favorite IDE. And I do want to say notable projects that use this was Jakarta EE9 was required to use a new namespace because the Java X namespace was branded by Oracle. And, so the Eclipse Foundation had to use a new namespace, which is now Jakarta, makes sense. And so that was one of them there. And then also Open Rewrite was used in, transforming the TCK for Jakarta EE. So, and I'm sure there's others out there, but these are the two big ones that use this technology. There was a great talk on Open Rewrite at Jakarta 1 2 days ago by Keto Man. If you want to look at that, it gives you more information on that. All right, so let's look at Payara Qube here a little bit. This, well, we have a slide on this. So this is a standardized secure platform, right, that will automate your deployment into the cloud or on premise. And it now includes Payara Cloud. Payara Cloud was released 3 years ago, and then now Payara Qube, or Cloud, is now Payara Qube. And then the big feature here of this is that you don't have to write your own app.yaml file. You can generate a project, and then it'll take all care of that for you, and the orchestration of that for your containers. So it is a subscription service, and there's a 15-day free trial. All right, let's see what else we have. So here's not a demonstration, just a flow chart of how things work in Kubernetes orchestration. You'll see in the left side, maintaining the Kubernetes cluster and going through all the different steps, as you can see, all the way to deployment. All right. So, and then it says that there has been an almost $83,000 development cost savings for this. So I, for one, tried using Kubernetes. I don't know, because my laptop's older, I had difficulty getting things going, so I kind of, I didn't have a chance to really wrap my mind around it. So this is, for me, someone who hasn't used Kubernetes or tried to anyway, this is a great tool for that. All right, so why Payara Qube? Okay, reliability and performance, right? You can deploy to multiple cloud vendors and multiple regions. If there's an outage somewhere in a region, another one can pick that up. Previous versions of an application can be restored. Security and compliance, there's the roles, there's the RBAC, roles-based access. Continuous monitoring, there's built-in monitoring and a metric dashboard for your applications and clusters, and scalability and flexibility. You can dynamically reallocate, compute, storage, and network resources, and there's auto scaling and scale to zero. So there's a lot here. This is relatively new. It only came out a few months ago. If you looked, I think there was the virtual Payara conference from earlier this year talked a lot about this. So you can look that up and learn more about it. All right, so let's take a look at Payara Qube, but let's take a look at an example here. So yeah, that'll be for later. So I'm gonna get out of this. I'm going to go to, we'll take a look at Payara Starter. So Payara Starter is similar to all the other ones. Spring Starter they're all, right? There's Spring Starter, there's Jakarta EE Starter, there's Micronaut Starter, Quarkus Starter, you name it, right? So of course, Payara is no exception here. And it's your, typical set of radio buttons and IDs here. So to make things faster, I'm just gonna say hello for easier typing later. And so we're gonna choose Jakarta EE10. You can choose the whole platform or just the web profile or core profile. We're gonna use Payara Micro. Let me explain that real quick. Payara Server is, the full server that, runs, the admin, UI and all that you can deploy. Payara Micro is a jar file. That is a way to start deploy one of your WAR files that you might generate as an application, and you can do it all with command line. Right? I like using that in my demos. Here we're gonna include some testing. For configuration, and we're using Java 21. And micro profile, you have your choice. So let's just pull, the full suite of, there we go, fault tolerance metrics. We're going to use Payara Qube, and then you have an ER diagram designer that you can use for various things. And then also security configuration, and to make things simple, we'll just leave it at none at the moment, but you have these choices to do authentication via file realm, database, or LDAC. So, and then you just do generate. And then you see in the upper right, it said hello.zip. So let's go there. So let's make directory. Oops, oh, that one exists. Hold on a second. It was an old one. so okay. All right. So there it is. So let's unzip it. Okay. So then let's open up IntelliJ IDEA and take a look at what we got here real quick, and then we can run this. All right. So of course, this is IntelliJ IDEA. You can use, you can use VS Code or NetBeans or whatever you'd like. I do pay for my own version of IntelliJ. So, but I've seen some of the other ones, and I know I see a lot of good stuff with VS Code, for example, from other folks' demos. You do get a okay. I have an older machine, so please I appreciate your patience on having things load. So this is what you get just by running Payara Starter. And then from here, you can add on whatever you'd like, right? So it creates a trust, please, yes. Okay, close that. So you get all of your various, you get a testing folder, you get a resources folder with microprofile configuration, all right? So, if you're familiar with microprofile config, this is standard. Here is where you can add things like for database connections and things like this, right? You have a web app folder. You'll see a splash screen when we run this. And then you have your hello world resource that, creates a path of hello and all that, right? And you have various things. You'll see some metrics things here, counted time, timeout. Retry is fault tolerance, fallback, the same thing. You have your fallback methods. And then your REST configuration is your standard, extending of the application, which is RESTful web services. Okay, and let's see, there's a testing folder. There's, probably a simple test, for that, right? So, and then a README file. I do have to, I have to fix a couple of things here. Actually, just one. The POM file, it does complain about having a version for JUnit We'll fix that real quick. Oh, I didn't complete that. Hit the tab too quickly. 4.13.2. Okay. All right. And I don't know why there's no. Okay, it should be fine. All right. So we're going to do. Let's see. It's MDN clean package Payara dash Qube :dev. I believe that's the correct way of doing that. So we're going to automatically deploy using Payara Qube. So this will take a few seconds. So I don't know if there's any questions out there at the moment. Don't have access to the chat right now. So you'll see some stuff. This is some of the stuff from Payara Micro. That's the output from there. But if you run Payara Micro by itself on successful deployment, you'll get the endpoints that were defined, and they flashed real quick just now. But it's going to deploy right now because we had in our POM file, which I forgot to show you. But you'll see there Payara Qube demo, and it says inspection process deploying, deployment process is deploying, and okay, and it says now it's deployed, and it should run. It says Chrome. Yep, there we go. So I didn't even have to find the URL, which was somewhere here. And again, because I had specified Payara Micro. And if you just use Payara Micro, somewhere around here. Oh, there it is. So because we're using, Payara Qube, the URLs are different. It would probably say hello in there, but this is what you get. And you see here, the get verbs right here. And of course, if you had some posts and, deletes and all that, I have a beer application that does all that. So, but it's beyond the scope of this. But anyway, yeah, so you see that it's up and running right now. So, there it is. All right. And then, again, this is very simple. This is to get things going, but it gets you going in like 5 minutes or less, right? And then you can, click on the hello world, okay? And then here, hello, John, and then I can say here, Mike, and then it'll put Mike on the screen. So, but again, this is just a starting point on there. My applications that I have for Jakarta have a splash screen similar to this, and then I have various endpoints for each demo spec that I have on there. So let's see, where are we? We're in the other browser here. Yeah, so let's go back. Oops, I have to go back to my, there we go. So to wrap this up, driving innovation, the road ahead. Basically, developers are key in this digital transformation in the automotive industry. Obviously, the Java language itself has evolved with features that address warm-up and load times. And by that, I mean Project Laden or Project Leiden. I've heard it both ways. And then there are right now 3 what they call JDK enhancement proposals, or JEPs, that are part of Project Laden, for that, for faster warm-up time. And, and there's also the technology out there known as Coordinated Restore at Checkpoint, or CRAC, which, interesting acronym for that. But again, that's a similar thing. It allows you to freeze something in time and then go back to it whenever you need. Jakarta EE and Microprofile, as you saw in the set of specs, they offer observability and resiliency for building cloud-native applications. Payara has been a trusted platform for secure, durable, standardized Java environments, and I believe it was 2014 they were formed. Or was that 2016? It was one of those. I know Payara is a downstream distribution of Glassfish, and their Oracle had dropped support for Glassfish. I think that was 2014. So, but yeah, there was a lot of work going on with that. So, And then tools such as Open Rewrite can assist in modernizing legacy Java applications. And with that, it's 8:45. I want to say thank you for listening to me ramble on for the last 45 minutes. So if there are any questions out there, Ross, I don't know, I can't see maybe I should go back here. Hold on. Maybe I can see it.
That's fine. Thanks, Mike. I've just rejoined. Yeah, okay. If you close that down, that would be great. Yeah, if you just close your screen down and stop sharing, Mike, and then I can just do the wrap up. That's right. That's it.
Oh, stop sharing. There it is. Okay.
Yeah, there you go. Wonderful. Yeah. If obviously we've got any questions, what we'll do is we've had people coming in and out. So what we'll do is we'll follow. We'll share. We've got a recording of this. We'll share that with everybody who attended, and also this will also be an on-demand webinar. But Mike, just wanted to thank you for your time. I thought that was absolutely fantastic. And like I said, we'll be. We thank you all for your time as well, and it was good to see you when we did.
Yep.
Thanks, everyone. So, thanks, Mike.
Appreciate it.
Bye-bye.
Okay.
Bye.
Bye.